In the quest to comprehend quantum theory, the role of computation is indeed fascinating. Computation offers valuable insights into the realm of physics, particularly quantum theory, which has been the foundation of physics since the 1920s. Quantum computation in particular provides a unique perspective. While we've only built small quantum computers so far, we aspire to create much more powerful ones in the future. The theory of these machines, intriguingly, operates within the framework of quantum mechanics, a theory that has persisted for 80 years. Rather than altering the theory, quantum computation prompts us to explore new questions and aspects. One of the most striking revelations is the realization that quantum computing requires an exponential amount of information to describe the state of a relatively small number of particles. For instance, with just 1,000 atoms, you might need a staggering 2 to the power of 1,000 numbers to record their behavior. This fact presents profound conceptual challenges for physics, emphasizing the importance of understanding the fundamental nature of computation within the physical universe. Furthermore, the interplay between computation and physics extends in both directions. Not only does computation help us understand physics, but it can also shed light on the limitations of computation itself. Consider the concept of Zeno's computer, which can perform an infinite number of steps in a finite time. While this sounds appealing, the physical constraints, such as energy requirements and the risk of meltdown, remind us of the inherent limits imposed by the laws of physics. These limitations, like the Beckenstein bound, illustrate that nature has its way of setting boundaries on what can be achieved. In summary, the relationship between computation and physics is a rich and intricate one. It offers insights into the nature of quantum theory and the fundamental aspects of both computation and the physical world. Exploring these connections not only deepens our understanding of the universe, but also raises intriguing questions about the boundaries that govern our technological and scientific endeavors.